I want you guys to start by jotting down anything you remember about a rational function. So an example of a rational function, just to make sure you know what we're talking about, would be like y equals x plus 3 over x minus 1, something like that. Think about how you find any of these pieces of information. We're going to go through how you find all of them. I want to know if you remember anything. Not a lot of writing going on, guys. Do you not remember? It's not fresh in your mind. Okay, well, let's look at this one then. All right, so horizontal asymptotes. That was the whole top heavy, bottom heavy, or equal when you're looking at the degree, okay? If it is bottom heavy, for example, y equals x over x squared minus 1. Okay, do you see how that's bottom heavy? Degree of the denominator is bigger. Your horizontal asymptote is always y equals 0. The other option is if the degrees are equal. So let's say we had y equals 3x plus 4 over 2x minus 1. Your horizontal asymptote would be y equals 3 over 2. If they're equal, you're just dividing those coefficients, okay? Is that vaguely familiar to you? Yes, okay, good. The other option is if it's top heavy, so if the degree of the numerator is larger, that's what gives you a slant or an oblique asymptote. So this is top heavy. So let's say we have y equals 3x squared minus 2x plus 1 over x minus 2. Everybody understand top heavy, degree of the numerator is larger? Do you remember what you have to do here? I don't know if you did a lot with this. Somebody said divide? Yes. So depending on how the problem is, completely up to you. If you can do synthetic division, I would. Some of them you're going to have to do long division. So I'll do synthetic division real quick with this one. 9. When you're finding a slant asymptote, your remainder means almost nothing, okay? It's not a part of the actual asymptote. So you can forget about the 9, and your asymptote would just be the line y equals 3x plus 4. And I think you guys remember how to graph lines, y-intercept, counter-slope. It's a slanted line, that's why it's a slant asymptote. Okay. All right, vertical asymptotes. How do we find those? Yeah, well, the denominator is 0, so x-intercepts. For some reason, everyone always struggles with your x and y-intercept. If it's an x-intercept, what do we know about the ordered pair? Y equals 0. So think about a fraction like this y equals x plus 3 over x minus 1. If I want the entire fraction to equal 0, which part of my fraction has to equal 0? Yeah, the numerator. So really, when you're finding an x-intercept, all you're doing is setting the numerator equal to 0. Okay. And you'll have graphs that don't have an x-intercept. That's okay. You'll have others that have more than one. All right, then the y-intercept is easier. What do we do with the y-intercept? Yeah, the x is 0. So all you have to do is plug 0 in for x. Domain and range, with those, you're just going to be looking at the graph to tell me the domain and range. All right, so we're not going to write, I think you guys know at this point, domain, we're talking about x values, ranges, y values, right? Okay. The extra box here, we should have a hole. Talk about when we get a hole in our graph. Anybody remember? Yeah, so if you have a common factor in your numerator and denominator. So let's say we have y equals x plus 1 times x plus 2 over x minus 1 times x plus 2. The x plus 2's would cancel out, right? Okay. That is gone. You now have this new reduced fraction of x plus 1 over x minus 1. So your hole happens at a specific ordered pair. The factor that canceled out, what would make that 0? -2, okay. How do I find a y value of my hole? Plug it into the new one, the reduced one. Yeah, so if I plug a -2 in there, what do I get? One-third, good. It's -1 over -3, so 1/3. And then question for you guys, this canceled out. Do you think I have an asymptote at x equals -2 also? Do not, no. Find any holes that exist first, and then use your reduced fraction to find everything else, okay? It's going to be a lot simpler from there. You can still find the exact same horizontal or slant asymptote. Your vertical asymptotes are the only from the factors that are left, okay? Same thing with your x-intercept. You're not going to have an x-intercept with that numerator factor. All right, let's try one here. Let's do f of x equals 2x. So I'm going to write the equation in the top here. 1 minus 6 over x plus 4. You guys want me to walk you through it, or you just want to try finding all of those pieces? I'll let you try for a few minutes, okay? And then I'll put it up there. I would not do the domain and range until the very end. So I know they're the first two things listed. I would do them last. can talk to each other too. Another point we haven't talked about, can you ever cross asymptotes? Okay, good. We'll distribute that. Horizontal, yes. What about slant? Yes. Horizontal and slant are the same. They guide the end behavior of your graph. They have nothing to do with what's going on in the middle of your graph. The vertical asymptotes, can we cross those? Okay, cannot cross a vertical asymptote. Start looking at this. Do we have any holes? No, none. Where is my vertical asymptote? Okay, and write those as equations. So it is x equals -4. All right, so let's do 4. All right. Your horizontal asymptote. What do you think? Y equals? Ooh, I'm hearing 0 and 2. What do we think? Is it bottom heavy or equal? Equal, then you divide, okay? So it is 2. All right. X-intercept, remember that comes from the numerator equaling 0. So what is, we only have one x-intercept, what is it? 3, 0, write it as an ordered pair for me. And my y-intercept, when I plug 0 in, what do I get? -3/2. Okay, so that's -1.5. Guys, that's enough points on that side of the graph to know what the shape is doing over there. Okay, your asymptotes are going to help guide it. It's going to follow the vertical asymptote and then follow your horizontal. We got to find just a little bit out about the other side. It's not going to have to be perfect, but I want at least a couple points over there. So the vertical asymptote was at -4. Let's just think about what we get if I look at x equaling -5 and probably -6. Those are nice and close. You can pick whatever you want over there. -5, what does that give me? 16. So that's off my graph, so I'm somewhere way up here. Okay. What about -6? We're getting closer. Okay, that one's there. Close enough, guys. There's your graph. Okay? How do we do? All right, let's do our domain and range from here. So domain, since we don't have any holes, what's the only x value that's getting skipped? -4. So you're going to say -infinity to -4. -4 to infinity. Okay. Now our range. It does look like on our graph we skip over that horizontal asymptote this time, right? So what is my range? Okay. All right. Questions on that one? Good so far. All right, let's try again. Let's make it a little more exciting. Maybe. I want to give you one with a hole. Okay, let's try this. Oh, sorry guys. Let's do x squared plus 2x minus 1. I'm sorry, minus 3 over x minus 1. This one's kind of weird. Always factor and look for holes before you do anything else. Okay. How's this one going, guys? Good? Kind of weird. Kind of simple. Do we have a hole this time, guys? Yes. What does that leave you with after you cancel out? What kind of graph are you left with? Do you have a vertical line? Okay. Yeah. Find holes first. Right. Yes. So technically you have a slant asymptote, but the slant asymptote is the line that you are drawing. So your graph very much follows the asymptote. It is the asymptote. Okay? So I'll help you out here. So your whole is at 1, 4. So vertical asymptote, none. Technically, you have a slant asymptote at y equals x plus 3. That's also what your graph is. Your x-intercept, what would that be? -3, 0. And what about your y-intercept? 0, 3, right? So you have this lovely line. Hopefully your line looks better. Okay? So it's weird to start with a rational and you end up with this, but that can happen. So what is your domain? Such enthusiasm there, guys. -infinity to what? 1, and then, okay, and what about your range? Infinity to 4, and 4 to infinity. Okay? Got it? All right, let's do one more of these. Let's see, which one do I want to give you? All right, how about y equals 5x plus 1? Or f of x equals over x squared minus 1. Try this one for me, guys. Sorry, 5x plus 1 over x squared minus 1. How many vertical asymptotes do we have this time? 2. Are they annoyingly close together? Yes. So what is that graph? Alright guys, how do we do on this one? Is it uncomfortable that the middle just goes right through your horizontal asymptote? But the ones with two vertical asymptotes you have to think about a little more because that middle section, sometimes it looks sort of cubic like this. Sometimes it's more of a parabolic graph, you know, you've got a parabola going on in there. So you got to think about it a little bit. And then again, I'm not looking for perfection here. I'm looking for, you know, think about some values to get the general shape, and that's it. Okay. Now, if you're drawing the right side of your graph here, first, if you have it on the wrong side of the asymptote, that's not a good sign. But if you have it, you know, going through like this point down here, that tells me you didn't really think about where it goes. So a couple of points over there is going to be helpful for you. As soon as I get through like a little more than 3, just under. Questions on graphing? We could do more. You're going to do more practice, more with slant asymptotes, all of those things, but we have to keep going to get through our nonlinear inequalities. So is there any part of this that you're not sure about? Okay, I guess we didn't write domain and range, did we? So domain of this one is not too bad. Negative infinity to -1, -1 to 1, 1 to infinity. What about the range? Yeah, negative infinity to infinity. So we've got that horizontal asymptote, but we crossed it, so we didn't miss any values on our range. Okay. All right. So let's keep going. Okay, nonlinear inequalities. So we're going to jump around on this page a little bit. So this first one here, there's two ways you can think about these. You can think about what the graph of the polynomial would look like, and then greater than 0 or less than 0, that's talking about above the x-axis or below the x-axis. Or we can do a number line test. I'm going to show you the number line test because you will need this calculus. Thank you. Okay, thanks. So what this is asking you, it is saying the product of these two factors has to be greater than 0. So what do you think the 2 points I want on my number line are going to be? -1 and 6. I'm going to label those. All right, so greater than 0, equals 0 at those 2 points. Do you think I want to include them? No, I don't. So I'm going to right away just put an open circle on each of those. Okay, and then I have to test the regions of my number line. So what might I test that's easy? 0, where is 0? In the middle, right? So if I plug a 0 in, do I get a positive or a negative in the first parenthesis? Negative, second parenthesis. Overall, that is a negative, right? Do you think this is going to alternate? Yes. How do I know that? We're just hearing. I'm hearing mumbles. Why? Why is it going to alternate? You're right that it does. Okay, thinking about the shape, yes, it's a parabola. That's where it crosses the x-axis. And we know that it just crosses the x-axis because there's no multiplicity with my zeros. Think about the polynomials when you were sketching. If the multiplicity was even, remember how it would bounce off the x-axis? That would change what your number line does here. Because there's no multiplicity, you know it just alternates from positive to negative to positive. And thinking about the graph is also very good. So those two are both going to be positive. Now you just have to make sure you answer the question being asked. I want to know, when is it greater than 0? So that's over here and over here. So guys, this is really the same thing we did with our domain in the last video. You guys remember? All right. So my answer would be negative infinity to negative 1 with parentheses. 6 to infinity. Okay. Let's try this again. We're not going to use the problem here. Let's do a new one. Let's do x plus 3 squared times x minus 1 times x minus 5 cubed. We'll stick with less than or equal to 0. So you can do your number line. If you really wanted to sketch the polynomial, you absolutely could, and you're telling me when is it at or below the x-axis. Okay, so I'll let you guys try that. Next up, number lines and graphs going on. So either way will work. We're getting there. All right, guys, so let's look. I'm going to go ahead and do the number line. If you graphed, that's completely fine. We should get the same thing. So right away, I know my inequality says less than or equal to. So am I going to be including this -3, 1, and 5? Yes, I'm going to put filled in dots on those right away so I don't forget them. What's easy to plug in? 0. Okay, so 0 plus 3 squared, that's going to be positive. 0 minus 1 is negative. 0 minus 5 is negative. Negative cubed is still negative. Positive times negative is negative. That is positive, right? Okay. This definitely does not just alternate nicely all the way across. We need to think about our multiplicity. So at -3, I have even multiplicity. What does that mean? My graph is stooping there. Bounces. So if it was positive, it's going to bounce and be positive again, right? Okay, so I know this side's positive. Then 1, does that have any multiplicity? No, so it was coming from the positive side. I would expect it to cross over and be negative after that. Now, 5 has multiplicity, but what does that cubed do? It's still going to change signs, right? It's an inflection, but it still goes from negative to positive, okay? All right, so now let's think about our question. When is it less than or equal to 0? Well, so that's in here. It's the only less than part. Be careful, though. Don't forget about the 3, because it equals 0 there. So your answer is actually, sorry, negative. -3 and then 1 to 5. If you wrote the -3 like that, I will accept it. The squiggly brackets, technical term there, that's actually more appropriate, but both of those, I understand what you're telling me. Okay. How many got that right and remembered the -3? Okay, a few of you did, good. It's tricky. Let's jump down to number 4. Skipping around a little here. So now I have this fraction that I have to deal with. It's kind of tricky to think about when a fraction is greater than 3, okay? Because that's just not a simple thing to figure out. It's much easier if you get a 0 over there, because now we're just thinking positive versus negative. So that's your first step, is to bring the 3 over. I'm putting that 3 over 1. Looking for a common denominator here, right? To subtract my fraction. So I'm going to multiply by x plus 4. So my denominator is x plus 4. In my numerator, I've got x minus 3, then minus 3x minus 12. Be careful with your signs there. So if I simplify that, I have -2x minus 15 over x plus 4 is greater than 0. Now we just graphed rationals, so if you want to think about your rational graph, you certainly can. I think the number line is quicker than graphing rationals for you guys. What do you think would go on my number line? Negative 15 over 2, good. And what else? What's your other guess? Negative 4, yeah. So negative 15 over 2 and negative 4. So which one would actually come first on my number line? Correction, Friday morning, we can do this. Negative 15 over 2, right? It is very important you get them in the right order on your number line, okay? So anything that makes your numerator 0, anything that makes your denominator 0. That's what we're testing on our number line, okay? All right, 0 again is easy to plug in. 0 in my numerator would give me a negative. And 0 is way over on the right for me this time, right? 0 in my denominator would give me a positive. So a fraction that's a negative over a positive is a negative. Okay. Any multiplicity with any of the factors in my numerator or denominator? No. So what do you know your number line is going to do? Alternate. So positive, negative. Okay, so let's look at it. When is it greater than 0? It's just in the middle, right? Am I including the negative 15 over 2 and the negative 4? So that's your answer. Parentheses, negative 15 over 2, negative 4. Okay. Questions on that fraction? What makes your numerator 0? Yep, good question. Yeah, so every time, anything that makes your numerator 0, anything that makes your denominator 0. We're going to skip 5 and do 6 here. But a question like 5, we're going to bring the 6 over. You're going to have multiple factors, right, in your numerator and denominator. So you're going to have multiple zeros coming from those values, okay? All right, let's do 6. This will be our last one with inequalities. Give that one a try for me. Bring that 3 over. the points on your number line, were they 14 over 13 and 5/3? Yeah, okay. So which one comes first? 14 over 13 or 5/3? All right, guys, so on this one, it says greater than or equal to 0, right? Did you get the outside edges? Okay. Greater than or equal to, you would think, yes, I'm including my 14/3 and my 5/3, but am I? I don't include both of them. Which one don't I include? 5/3. Why? Right, 5/3 would give me a 0 in my denominator. So it's tricky. So this one, yes. This one, no. Okay. What? 14/13. Sorry, I think I said 14/13. What about them?
They're very close.
They are, yes. That's why it's nice that we know it alternates and we don't have to find a value in between them to test. We don't want to find that value. So.
How do you know it alternates when there's not a cube, right?
When there's not a quantity squared. Because even if it's cubed, if it's quantity cubed, it's still going to alternate. If you graphed it, it'd be like an inflection.
If anything squared, it can't alternate. Otherwise,
yeah, then you have to think about what it's doing. Because remember when we graphed polynomials, that's when it bounces off the x-axis. So if it was positive, it stays positive. So that is our answer for this one. How do we do on that one? Did I trip you up with that whole not including the 5/3, or do you get it now? Okay. All right. Questions on nonlinear inequalities? Getting there, guys. All right. Let's keep going. We have 11 minutes left. All right, partial fraction decomposition. So this is completely different than anything you've ever done before, okay? So what we are doing is sort of undoing the finding of a common denominator with a fraction. We're kind of working backwards. So this would have equaled a over 3x minus 5. B over x minus 3. Like, do you agree if I started with two fractions that had these two denominators, this would be my common denominator? Okay, so we're kind of undoing that, but we need to figure out what A and B are, because you can't just do, you know, the x over 1 and the minus 1 over the other. That doesn't work, all right? You have to figure out what were A and B so that this is my numerator when this is my common denominator, okay? So there's a process for this. I am going to multiply the entire thing by these common denominators. So by the 3x minus 5, the x minus 3. Getting rid of the fractions in the very first step. So what is going to be left on the left side of my equation? X minus 1, right? Okay, then what is A going to be times? Just the x minus 3, right? Okay. And B is going to be multiplied by 3x minus 5. Okay. There's two ways to do this. There's a long way and a short way. Anybody want to see the long way? Should we just go to the short way? All right, let's do it. So, from here, what we can do is pick some x values. I'm going to let x equal something. What would make this 0 if x were 3? So I'm going to go ahead and do that. I'm going to say x is 3. All right. If x is 3, the left side of my equation would be 3 minus 1 equals, is any part of that A term even going to be there? Yeah, it's 3 minus 3 is 0. 0 times a, it's gone. So I would just have b times, what, 9 minus 5? So I get 2 equals 4b. So what does b have to be? 1/2? Okay. All right, so I've found part of it. Okay, for the second one, we get to pick something else for x to equal. Now you actually have a couple of choices here. What would eliminate the b term? 5/3, you can certainly do that. If you'd rather, since we already know what b is, we can use that and use like x equals 0 because that's simple. Either way works. Should we do the 5/3 and just eliminate things on this one? Okay, so we're going to let x equal 5/3. So I have 5/3 minus 1 equals a times 5/3 minus 3. And there would be no b term, right? Okay, so 5/3 minus 1, what do I get? 2/3. What about 5/3 minus 3? Negative 4/3, right? So negative 4/3 a. So how do I get a by itself? The switching, yes. So multiply both sides by what, negative 3/4? Okay. So what do I get for a? Negative 1/2, okay. All right. We found a and b. Now we can actually write our answer. A was negative 1/2, right? I don't really want a fraction within a fraction. How do you think I can write that without it being like a 3-level fraction? What?
0.5.
Okay, turning it into a decimal is just a cheaty way to still have a fraction in your fraction. I could leave the negative 1 up here and do 2 times 3x minus 5. That's what that means, okay? So I'm going to say negative 1 over 2 times 3x minus 5 plus, so then for b, since it was 1/2, I'm going to do 1 over 2 times x minus 3. That's a minus, I promise. That's your answer at the end. Okay? Nope, because I want you to show that these are the denominators, these are still there, okay? Question? All right. Let's jump all the way down to number 3, because this one is a little different. You see how it has 2 factors, but one of them is a quantity squared, okay? The way you have to break this apart, we're going to have a over x minus 3 plus, we're going to have b over just x plus 1, and then c over x plus 1 quantity squared. I know it's weird. Anytime you have a repeated factor, you have to show it by itself and repeat it. So if it was like x plus 1 to the 4th, you'd have x plus 1, x plus 1 squared, x plus 1 cubed, x plus 1 to the 4th. I'm going to do that to you, okay? But you show that it is a repeated factor when you go through this, okay? So what would I multiply this entire thing by? All of those denominators, right? So I'm going to be left with 1 equals a times x plus 1 squared. B gets multiplied by an x minus 3 and an x plus 1. C gets multiplied by just an x minus 3. Does that make sense? So it's this denominator over here that was your common denominator. That's what you're multiplying by. You have to show that it is a repeated factor. If you just did x plus 1 and x plus 1, that's not going to actually get you to a common denominator of x plus 1 squared. And you can't just put one term in there. You can't just have a over x minus 3 and b over x plus 1 squared. It doesn't work. If it's a repeated factor, you've got to write it out like this. Okay. All right. So again, we're going to let x equal some things. What should we let x equal to begin with? -1, yes. So I'm going to get 1 equals. Will any part of that a term be there? No. What about the b term? No. C? Yeah. What's that going to be? -4c, right? So -1/4 is my c. Okay with that? I know I'm moving quickly, guys. We have 2 minutes. Okay. We're going to get there. What else do you want to let x equal? 3. Okay. So I would get 3 plus 1 is 4 squared. I get 16a, right? Would any part of b be there? Any part of c? No. So I know a is 1/16. Do we have anything else from the problem to let x equal? No. So what might be easy? 0. Let x equal 0. So you're going to have 1 equals, then it would be 1a minus 3b, right? And minus 3c. Plugging in a 0. That's 3 variables, but do I know 2 of them already? Okay, so let me just talk you through this because I need to talk about your homework too. You plug in what a and c equal, because you already found them, and then you could solve for b, right? Okay, are you with me? I know this was quick today, guys. So let's look at your homework. Ugh, we cannot do all of this. Let's go evens on your homework, okay? You also have a take-home quiz, but it is not due next class. So guys, with the take-home quiz, obviously time does not matter, but I would like you to do it on your own. And it is still no calculator, okay? It does get graded as a quiz. All right, everybody clear on what we're doing? I know that was a lot. Okay. All right, evens on the homework. That's actually due next time. Take home quiz due next semester. Are you okay? Yes? Didn't overwhelm you today? Just a little? Okay. I know that was a lot to get through. We will do more practice in our warm-up next time, though, okay?